Okay, this morning we're going to talk about sine and cosine on the unit circle. So before we do that, we're going to want to fill in our unit circle. So draw yourself a big circle on the XY coordinate axis. And let's fill in some of our angles. 0 degrees, the top is 90, the left is 180. 270 at the bottom, and finally one rotation is 360. And of course, we learn that, as we move on towards calculus, we tend to measure these in terms of radians. So of course, 0 degrees is 0 radians, but 90 would be pi over 2. Of course, we know 180 is pi. That's our main conversion. 270 would be 3 pi over 2. And then finally, 360 is 2 pi. So it's kind of important every now and then to just mark up a circle, especially in the context of what we're about to be doing here. Finally, this is called the unit circle because the radius is 1. So, we actually can write down some order pairs here on the circle. To the right, that's 1, 0, because the x-coordinate is 1, and we're not going up or down. The top here is 0, 1. On the left, -1, 0. And let's get that correct. And the bottom coordinate here is 0, -1. Okay. So once we have that, we're going to actually talk about two functions. We're going to talk about the sine function and the cosine function, which are abbreviated by their first 3 letters. Sine is defined as the y-coordinate divided by the radius. And of course, on the unit circle, the radius is just 1. So honestly, on a unit circle, you could think of sine as just the y-coordinate because the radius is 1. Cosine is defined as x over r. Of course, on the unit circle, r is 1. So on the unit circle, cosine is just the x-coordinate. Okay, so what does all this mean? So I'm going to flip ahead, look at a couple problems here. Okay, there's some definitions. And I mentioned in geometry, sine we looked at, and sine and cosine we looked at in terms of a triangle, a right triangle. But now we're going to look at it in terms of a circle. And if you could think of that unit circle I just had, and I might not do well here, but think of that's terrible. Think of a circle kind of going around here. I'll just do a part of a circle, right? Right there, that's the x-coordinate and the y-coordinate. And if you look at it, there's a tie into geometry. The y-coordinate's the same as opposite, the x-coordinate's the same as adjacent. So, but really, I just want to look at those 4 main angles, 90, 180, 270, and 360. So if I said, what's the sine of 90, right? I'd have to actually scroll back to my unit circle. There's 90. Sine is the y-coordinate. So the sine of 90 is just 1. It's actually just that easy. Sine is the y, cosine is the x. That's kind of the first lesson here. So if I want the cosine of 90, and excuse me, I got to keep scrolling, but I kind of, on your desk, I would have the unit circle on one side and I have the problems on the other. But if I want the cosine of 90, cosine is the x-coordinate. So cosine of 90 would be 0. Sine of 270, look at your unit circle, that's at the bottom. The y-coordinate at 270 is -1. And then finally, cosine of 180. Cosine is the x. The x-coordinate 180 is a -1. So over at 180, the cosine is -1. Simple enough, right? Does it work in radians? Of course it is, right? So, switch your brain over radian mode. We already have it on the unit circle. Sine of pi, pi is over at 180. The y-coordinate there is 0. Cosine of pi, there's pi. Cosine's the x-coordinate, that's -1. Sine of pi over 2 is up top. The y-coordinate there is 1. Cosine at 3 pi over 2, that's at the bottom of the circle. That's the x-coordinate is 0. So, for our purposes, if you just remember, sine is the y-coordinate, cosine is the x-coordinate, I think you'll be in really good shape. Hope that helped.